Right, so hi guys, we are back once again and we are still continuing with financial mathematics. We did simple interest, we did compound interest, and in this video we will be talking about nominal and effective interest rate. Right, so let's talk about nominal and effective interest rates. Right, so because it's interest rates, it means we are dealing with percentages, right? Yes, because we said interest rate is the same as interest, but what is the difference? The difference is that interest rate is the percentage. So this is the most simplest part of financial mathematics. Okay, it's the most simplest part of financial mathematics, and I believe no one should be getting this part wrong. Okay, because straightforward. So what is nominal? What is nominal interest rate? Nominal interest rate, it's just the rate that is advertised or the rate that is stated. Okay, so it's just advertised. Let's say, for example, the bank is saying we will pay you 12% per year compounded monthly. Okay, they are stating that, they are advertising that they will pay me 12% per year compounded monthly. So that is a nominal interest rate. It does not show you how much you will actually earn. Okay, they are just advertising. That is a nominal interest rate. And then effective interest rate is the one that tells you, or that shows you how much you will actually get. Okay, nominal, it's just advertising, and then effective, as this is the interest rate that tells you how much or the amount that you will actually get or earn. Okay, and then to calculate nominal and effective interest rate, we use the formula which says 1 plus IFF. What is this IFF? It's I effective. It's effective interest rate, which is equals to into 1 plus I nominal interest. It's nominal interest rate divided by M, and then to exponent M. Okay, so this is the formula that we are going to use when we are calculating nominal and effective interest rates. And unfortunately, this formula is not in your data sheet. It's not there in your data sheet, so you need to know this formula by heart. Okay, so what is we said I effective, it's effective interest rate, right? And then I norm is nominal interest rate, and then M, what is M? M is your compounding period. Compounding period, you remember compounding period, different types of compounding period: semi-annually, annually, quarterly, monthly. So M is compounding period. Okay, right. And about nominal interest rate, nominal interest rate is usually compounded with different compounding period. Okay, and then effective interest rate is compounded annually. Okay, so let's take examples here. I've got a couple of examples. Okay, so number one, they are saying convert a nominal interest rate of 7% per annum compounded semi-annually. So what are we giving in this case? I'm giving a nominal interest rate of 7%, that is 7 over 100, which is going to give me 0.07 compounded semi-annually. Semi-annually means twice per year. Okay, so it's 2 times per year, right, to the effective annual interest rate. So we are required to calculate I effective. Which formula are we going to use? Of course, we are going to use this formula 1 plus IFF is equals to into 1 plus I nominal interest rate divided by M or to exponent M. So I'm required to calculate I effective. So I need to transpose 1 to that side so that I'm left with I effective, which is equals to 1 plus I norm, it's 0, 0.07, 0.07. M we said is our compounding period. In this case, we are dealing with semi-annually. Semi-annually twice per year. So we are going to divide by 2, and of course 2 there, but don't forget you transposed 1, so that is minus 1, and then you take your calculator. Very simple, right? Very simple. So you take your calculator, then this is 1 plus 0, 0.07 over 2. I'll take 1 and 2 minus 1, and then this is 0, 0.07 1225, right? And then you will multiply by 100 so that it becomes interest rate as a percentage. So the answer that you will get, you will always multiply it by 100. So this is 7.12%. Please ensure that you do not convert your answer into 2 decimal place. Please, right? So this is 7.12%, and that is our I effective. Okay, let's move to the next question. Question 6. Patrick deposited an amount of 18,500. Okay, so 18,500 is our present or our principal amount. So it's 18,500 into an account earning R% interest per annum compounded monthly. Okay, so we are dealing with compound interest here, right? So we are giving the interest rate as R%, that is R over 100, right? Compounded monthly, and they're saying after 6 months, okay, after 6 months, his balance was 19,319.48. So what is that balance? This is accumulated because it's the final value after 6 months. So it's 19,319.48. And then for 3 marks, we are required to calculate the value of R. So we said this is compound interest. Okay, so it's A is equals to P into 1 plus I all to exponent N. This is the formula that we are dealing with for compound interest. In this case, I've got A. So my A is 19,319.48. And then I've got P, which is 18,500 into 1 plus I've got R over 100. But remember, we are given a compounding period, compounded monthly, so I need to divide this by 12, right? Monthly 12. So let's simplify this, okay, because I have R over 100, R over 100 divided by 12. So I'll just change this division into multiplication, then it becomes 1 over 12. Numerator becomes denominator, denominator becomes numerator when you change that division sign. So R multiplied by 1 is R over 12 multiplied by 100, that is 1,200. Okay, then I write R divided by 1,200, and then leave this as it is. Leave n as it is. Leave n as it is. Okay. No. What am I doing now? Leave n as it is. No, 6 months. Yes. Because we want to calculate the value of r. Yes. So n in this case is 6. 6 months. 6 months. Okay. Let's erase that. 6 months. 6 months. Yes. 6 months. Okay. So let's let's simplify this. So you will divide by 18,500 on both sides. 18,500. Then this will cancel this, and then I'm left with 1 plus r over 1,200 all to exponent 6, which is equals to 19,319 comma 48 over 18,500. Then after I want to remove this 6. What am I gonna do? I'm gonna introduce sixth root. Sixth root, yes. So I introduce sixth root on both sides. Sixth root, and then I'm left with, let's erase, it's for 3 marks, but hey, you have to work, because now I have removed that exponent of 6. Then I'm left with 1 plus r over 1,200, which is equals to the sixth root of 19,319,48 all over 18,500. Then I transpose 1 to that side. Then I'm left with r over 1,200, the sixth root of 19,319,48 divide by 18,500 minus 1. Then cross multiply. 1,200 is going to multiply that sixth root sixth root 1,200 is going to multiply that sixth root, and of course together with -1, right? So hence I'm gonna introduce 2 brackets, and then sixth root of 19,319,48 divide by 18,500 minus 1. Then you close that, and then take your calculator, ensure that you press your calculator correctly. Okay, so sixth root 1,200 into sixth root of 19319,48 divided by 18,500 minus 1. This is equals to and already this is given as a percentage, 8.7%, right? So it's 8.7%. So that is the value of r, and then calculate the effective interest rate. So this is our I norm. Why? Because we just said I norm will always be compounded with the compounding periods, okay, which in this case is compounded monthly. Effective interest rate is compounded annually. So you will never talk about compounded monthly, compounded annually, compounded semi-annually with effective interest rate. So 1 plus I effective is equals to into 1 plus I nominal over m all to exponent m. Then I transpose 1 I effective is therefore equals to 1 plus I norm is 8.7%, and 8.7% it's 8 over 100, which is equals to, right, it's 8.7 divided by 100, right, which is equals to 0,087. So 0,087 divide by, they said compounded monthly. So remember, M is your compounding period. So this is 12 minus 1. And then your I effective is equals to 1 plus 0,087 divided by 12, all to exponent 12 minus 1, and this is equals to 0,09055, followed by other numbers there, and then I'll say that answer multiply by 100. This is equals to 9,06%. Yes, and that is your I effective. Okay, guys, we will be back again, still on financial mathematics, and I'll see you sharp.